All right, if we're looking at this right here, properties of chords. Remember, the chords are the start and stop on the circle somewhere. So AB would be a chord, CD would be a chord. The first rule says, in the same circle or congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. What does that if and only if mean again?
It works both ways.
Works both ways. So this is saying the arcs are congruent if the chords are the same. Well, I could flip it around and say what?
If the chords are the same.
If the chords are the same, then the arcs are the same. All right, remember, where are the arcs at?
Or from like one point to another.
But where?
On the outside.
Outside of the circle. So in this case, I could say
AB
if segment AB is equal to segment CD, then what else is going to happen?
arc AB is equal to arc CD.
There you go. So that's what this rule is saying. If the inside parts are the same, the chords are the same, then the arcs are the same on the outside. But since it says if and only if, what else can I say?
That if arc AB is equal to arc CD, then it's equal to segment AB equal to segment CD.
There you go. All right, this first rule says if one chord is a perpendicular bisector. What does perpendicular mean?
Up and down.
Mercy God.
Makes a right angle. Perpendicular means makes a right angle. Bisect means cuts in half. So if one chord makes a right angle and cuts the other one in half, then the first chord is a diameter. In other words, this.
Means that one up.
If you see this going through the center, and these two parts are equal, then that first one has to be a diameter. Even if it's not marked, it has to be. All right? So, if one chord is a perpendicular bisector, then it has to be a diameter. So what you'll probably see is that right there.
And then you
So if I see that, then I know it's got to be a diameter and go through the center. The second one says, if a diameter is perpendicular, then it cuts it in half. So what that would be is something like this. If I see that right there, so I've got a diameter because it's going through the center and it makes a right angle, then I can say those two pieces are the same and those two pieces are the same. All right, so let me write that out. Let's see, what would we say? We would say if AC is perpendicular, remember that little symbol means perpendicular, to BD, then I know that BE is equal to ED and arc BC is equal to arc CD. Last one. All right, this last one says, in the same circle or congruent circles, two chords are congruent if and only if they are equal distance from the center. So, again, what does that if and only if mean?
both ways.
You can switch the rule. The first way it says the chords are congruent if they are equal distance from the center. So that would say that AC is equal to EG if BD is equal to DF. The chords are congruent if they are the same distance from the center. But then if I flip it around, I can say what?
BD is it?
Actually, I need to do this. Let me rewrite this. If AC is equal to EG, then that.
BD.
And then flip it around and say, well,
If
if BD is equal to DF, then AC is equal to EG. All right. Now we've got basically three rules. The first one says if the chords are the same, the arcs are the same, or if the arcs are the same, the chords are the same. The second one talks about the diameter and being perpendicular, it cuts things in half. The third one says if it's the same distance from the center, it's going to be the same for the chords. Which one would number one be?
The first one,
The first one. It's saying, it's telling me that arc BC over here is 121 on the outside. Alright? And I know if
They're both the equal distance.
the chords are the same on the inside,
And they equal the same.
then the arcs have to be the same on the outside. So it'd have to be 121. That's how simple those are.
Alright.
If the chords are the same, the arcs are the same. I could flip this around. If I had the 121 on the outside and one of these was a 7, then the other one would have to be a 7 on the inside. All right. The second one, which rule is it?
The second one? No.
The third.
Just
Third.
the third one.
Is it?
first,
It's the same as the first. What is it telling me is the same?
the chord,
Nope.
or wait,
If the arcs are the same on the outside,
the chord's gonna be.
then the chords have to be the same on the inside. So if it tells me 125 and 125 for the chord, or excuse me, the arcs, then I know that BC has to match
12.
FE. It's got to be 12. Alright? If the outsides are the same, the inside is the same. If the inside is the same, the outside is the same. Alright, number 3. This one people miss all the time.
That one's the first one.
What's the answer right here?
140.
One.
It'll be AD or DA. One of
It's
them.
gonna be 40.
140.
It's gonna be 40 because it equals 180, right?
80.
But
The only time I can do 180 is if I go through the center. Nothing's going through the center, so I can't use the 180.
see,
So
both
you
the
get
chords are the
360.
equal. Both of the chords are equal.
You did 360, right?
No, both the chords are equal, and
360.
one's 80, so the other one's gonna be 80.
Alright, that I can go with. Most people do what you did first. You say, oh, well, there's 140. That's going to be 140. That is not right. What you need to do is say, well, this chord on the inside, AB, is the same as chord CD. So if those chords are the same, then what does that mean for these arcs?
They're the same.
Alright, so that would be 80. But is that what it's asking me for?
Yes. No, it's asking for the
No,
arc.
it's asking me for that part up there.
So just add all those up and then subtract.
So then I would have to add and subtract the 360. So I would do 80 plus 80 plus 140 and get 300. Then do 360 minus 300. So BC
I
would
thought
be
it
60.
was why are they 140?
Because I don't have a chord here matching it. See, this says if the inside chord is the same, then the outside arcs match. There is no chord that matches up with that 140. Alright? Alright, which rule is this?
Second one.
Second one, because we're talking about a diameter and perpendicular and all that stuff. The rule says this. If I see that it goes through the diameter and makes a right angle, what can I know about that figure?
Then it cuts it.
Cut stuff in half. So I now know
That.
that is equal to that. Does that help me in this problem?
Yes, because they're equal.
Whoa. What I just marked.
You mark the chord.
That means both sides are equal. That means 80 minus X
X is
equals
equal.
40.
That's what I wanted to get to. This part right here really doesn't help me because I've got no numbers and nothing to work with. What does help me is if these are the same,
You can turn it into a one.
then I can say BC is equal to BE. So I now know that arc BC is equal to arc BE.
That's 5 divided by 80. 80 divided
So I'm going to
by
say 4x equals 80 minus x.
Then you can subtract that X.
Not subtract it.
Or
Well,
add
add it. It'd be 1X. Because always X.
it. And that's gonna be 16.
Alright, so x will be 16, but here's what you're going to have to do after that.
Add it up.
Nope. You're going to have to say, what is BC? What is BE?
Huh?
All right, so now I know what X is. How does that help me solve for all these arcs?
So you can,
You got the on
you know that BC equals, be 16 times 4.
All right, I'm going to start with the easy one. I'm going to take this 16 and plug it into both of these. What should happen when I do that?
You get them two arcs, and then the other ones you can do.
But what should happen with those two arcs?
They should be the same.
They should.
They better be the same. If they're not the same, then
So you
16 is
plug
wrong.
16 into 4.
So for BC, I'm going to say 4 times 16, you
64.
get 64. And then for BE, I'm going to say 80 minus 16, which is,
64.
so now I know that I've got the right number and I can start working the rest of it.
So BC equals 64.
All right, so BC is 64, BE is 64. How would I find CD then?
Right, that's a semicircle with CD, so subtract 64 from 180.
All right, if I look at this bottom or top half, excuse me, top half of the circle, that's a semicircle. Semicircle has to be 180. I know this part right now is 64, so I would do 180 minus 64 and get 116.
BEC.
All right, what about BEC then?
It's going to be a major in this.
All right, how do I find it?
You will do
Subtract
64 minus
64.
360.
All right, I know this part right here is 64.
It's going to be 290.
It's gonna be major because it's greater than what?
All right, so
It's
this
going
is
to be greater than
64.
a semi.
I need to know what ED is and CD we just said was 116.
It's 296.
How much is
116.
Give me some.
the other way of looking at it is to say BEC is everything except
That's 64.
BE.
that 64 at the top right
So
here.
you do 360 minus 64, and you get 296.
What a 290.
The other way of looking at it is saying if I go around the circle BEC, I would add up this 64, this 116, and that 116. Whichever way works for you. All right, what about EDC?
Be 230, no, 44. 13.
Just add up the two 116s there. And then CE, how much would that one be?
64 plus 64.
Really what you should probably do, and I didn't do it in the right order probably, is once I find these 64s, I should probably say, okay, if that's 64, what is this?
Yeah, go ahead.
And go ahead and find that. If this is 64, that should match these two things, then I can start working the whole circle. That's probably a better way of doing it. All right, are there any questions on that right there?
No, sir.
First thing you're gonna do, if it goes through the center and makes a right angle, the two arcs have to be equal, the two inside parts have to be equal. Find X, plug X back in, find those arcs, find the rest of the arcs, and then you can solve the circle.
Rule number 2.